Why is it hotter in summer and cooler in winter? I've got a pretty poor diagram here, but I want you to imagine that that's the sun. The orange lines are light rays or rays of energy and heat that are traveling towards the Earth, and obviously there's a blue ball as the Earth. Right, so you can see in this one the southern hemisphere is tilted towards the sun, the northern hemisphere is tilted away from the sun. And what I was going to do for you is draw some lines on the Earth. You can see that this part of the ocean here is roughly 90 degrees or perpendicular to the sun. And let's see, 1, 2, 3, 4. I'm going to go and draw a line, whoopsie, that covers about 4 of the rays. So there's 1, 2, 3, 4. So there's a nice short line. I'm going to draw another one in the northern hemisphere, which remember is experiencing winter. I'm going to cover 4 of the rays as well, and let's see if we can see any difference. 1, 2, 3, 4. Has had to cut through the Earth a bit to make a straight line. Hopefully you can see, and I'm going to zoom in here, hopefully you can see that these lines are all equidistant, but because of the angle of them, the distance between these 4 in summer is much shorter than the distance between these 4 in winter. And I did that to illustrate that when the Earth is tilted towards the sun, it gets hotter. When the Earth is tilted away from the sun, it gets cooler. It's just like how people, if they want to warm up in the sun and they want to sunbake on the beach, they usually lie down and they face the biggest part of their body towards the sun. And it's also why, if you've ever noticed where you get sunburnt, if you're standing up, you'd normally get sunburnt on the parts of your body that face towards the sun, like the tip of your nose or the tops of your ears or your shoulders. Because that sun's energy is far more concentrated on objects which are facing towards it than objects that are on an angle. So I hope that makes sense.